Welcome to my very first Q&A session. We've got about 53 questions, mostly on van electrical systems, and I think it's going to be really useful. It was awesome for me to see the latest questions that people have here at the end of 2022, and it's also, I think, going to be really useful for people to hear all of these somewhat technical questions answered about mobile power systems. And I'm just going to roll through this. You guys are going to see how much I actually stutter on camera, but I'm going to do it in one take. And we may have some cars driving by and things like that, but I'm going to go ahead and just roll forward with the first question here we have from Carol. Carol is actually a student of mine, and I have a photo of her system. Her question is, I'd like to trickle charge my van's battery when I'm camped somewhere. This past summer, I drained the van's battery going in and out of the side door while I was parked for a week, not connected to shore power. What do you recommend for this, and how would I set it up? She's got a Victron Multiplus and 4 Battleborn batteries. So the Multiplus and the Battleborn batteries in the back are somewhat not related to the solution here. I noticed that she has a non-isolated Orion Victron 30 amp charger, which is what I recommend in my course that she followed, and or it's one of the recommendations. There's also a Sterling that I recommend. Basically, these are one direction chargers, and so it's going to go from the engine battery to the rear batteries. And what you need is a bi-directional charger. The old relays that people use would allow the power to flow the other direction, but the modern chargers that we need, because they restrict how much flow, how much current is coming from the front battery, they are typically one direction. Whether they have a diode or whatever they have in there, the power can only go one way from your front battery to your rear batteries. And so the way that you would solve this with the Victron Orion is you could put a little switch right below the charger, and basically when you turn on that switch, it's going to allow an alternate path for your rear batteries to charge that front engine battery. And so batteries are basically like water tanks. If one of them is at a higher voltage than the other and you connect them with a line, the voltages are going to try to equal out. And so that's what would happen. Basically, if you have solar or shore power or some kind of charge source on those rear batteries and you give it a path to the engine battery, it'll go ahead and charge your rear batteries as well as the engine battery. So I would get the Bluetti 6006 switch, and basically when you have your Victron Orion charger, the line that says in, you would basically stop at one side of the Bluetti switch and then go up into the in port of the charger, and then on the out, instead of going straight to your rear battery system, you would go to the other part of the switch and then go to your rear battery system. So basically you're going to stop at the switch on those lines going in and out of your charger, and that switch is going to remain off 95% of the time. But when you park for a week and you want to connect those rear batteries to your front battery, you can turn that switch and it'll basically give an alternate path for the electricity to flow through the switch to your engine battery, and it will bypass the charger. Now, if you leave this on and you try to drive down the road and charge your rear system, you've got to bypass around the charger, and so it'll go ahead and pull 100 amps. If your rear batteries are really run down, it'll pull too many amps, and your charger won't be regulating how many amps are coming off of the alternator at that point. So this is kind of like an emergency switch that you could use to bypass the charger if you're going to park the vehicle and you want that front engine battery to charge as well. So that's my question. I'll go ahead and, or that's my answer. I'll go ahead and leave it at that. Let's move on to the second question here. It's from Deon. He says, "Hi Ross, I want to run a 12 volt air conditioner in my van and plan to have 800 amp hours of battery capacity, which in theory should be okay. Most van builders I speak to recommend 110 volt units. Why is this? I want my system to work off grid as well as on shore power when available. Could you please share your thoughts? Thanks." Well, I have pretty much completely moved away from the 110 volt units because you said off grid. Once you go off grid, the 110, 120 volt units are pretty much out of the question because they are just going to eat your batteries. The smallest of those units is going to take 1500 watts. Most of them are going to take around 2000, especially once you run them through an inverter. So that's where you're losing 10 to 15% of your battery power just running that air conditioner through an inverter. So you have to have a big inverter to do that. And I like to get the 12 volt units and run them straight off the batteries. Now, if your batteries are 24 volt or 48 volt, they have basically DC air conditioners that are 24 or 48 volt. Pneumatic Cooling has some of those, and they're basically going to go straight off your batteries without an inverter. The key word is off grid. A lot of these air conditioners were built for when RVs were basically plug to plug. You would plug them in at home. You had a little lead acid battery bank that really didn't provide much more than turning on the lights. And then you would go to the campground and plug in again, and all of a sudden you could run everything. The RV designs have really gotten away from that, or the van designs have, because they're majority of the time off grid, which is how I like to camp. I didn't grow up in RV parks, and when I go there, it looks like a parking lot to me. And you know, I've spent a lot of time camping at Walmarts and stuff like that, and there's a time and a place for that. But if I'm on vacation, I don't want to park amongst 500 other RVs. So I want to get off grid, which means I'm running on batteries. I'm going to have a larger lithium battery bank, and I'm going to have a DC air conditioner for direct current running on 12 volts or 24 volts or 48 volts, whatever my battery bank voltage is. I'm going to have an air conditioner that pulls straight off of those batteries without an inverter. And for whatever reason, these 120 volt air conditioners, they're taking 1500 to 2000 watts. And the DC air conditioners end up taking like 400 watts. I don't know what the discrepancy is, but the 120 volt air conditioners, like the Coleman Mach units that are put on a lot of RVs for the last 10, 20 years, they just eat power compared to the DC air conditioners. You're going to pay about 3 times the price for the DC air conditioners. You're going from $1,000 to $3,000. But for off-grid scenarios, there is no way I would put a 120 volt or 110 volt, as you called it, air conditioner on my off-grid van or trailer or whatever it is. So that is my answer to Deon. Thanks for the question. Question 3 from Mike. He says, I like Victron products a lot, but I'd like to mix and match where I find better value. Specifically, I find their lithium batteries very expensive. I know they advise against using the competition's batteries, but is there a technological reason to back that up? I would like to see you or someone address and explore this from a scientific, technological perspective. Thanks. So in my system designs that I give to my students, there is a lot of Victron products. Occasionally I will switch out to another brand. I mainly do that for the quality of the products, but also the monitoring capabilities with things like the Servo GX. I want everything on one screen. To me, that is very important, not to have a control center with lots of junk in the control center. But when it comes to the batteries in the designs that I feature, they're not Victron batteries in there. That's the one thing that I will switch out for Battleborn or BigBattery.com. Trojan Trillium is a favorite battery that I really like. I don't see very many people use it, but the specifications on that are awesome. You could also switch to the Victron Super Pack. Basically, the batteries that have a built-in BMS or battery management system in the top of the battery, I feature those in my designs because they're simpler and it's a little bit more fail-safe to have that BMS shut the battery down if anything goes wrong in your larger system. What I've noticed though is the smart lithium batteries from Victron in particular, people are still using those. Those were the first lithium batteries I started with in 2018. And you have a BMS, a little black box, and you have to wire it to all these switches. And I thought that people would get away from that if they could just get the BMS built into the top of the battery. But what I've noticed is people are still using those. My students are using that system. The van shops that I see on Instagram are still using that system. So from a technological standpoint, I like that the smart lithium batteries in particular from Victron, those batteries can control, they reach out into the system and control the chargers and loads, and they turn things on and off. So it's a little bit more intelligent way. Instead of just disconnecting the battery in an adverse situation, they'll actually go out and turn off your solar, turn off your shore power charger, shut down your loads. So there's some sophistication to it in that regard. But other than that, I would say using any other battery brand like Battleborn is fine with the Victron products. If you want to switch out the batteries, I don't think there's any issue with that. You may have a longer warranty. Some of the battery companies are getting to 10 and 12-year warranties, and I don't think Victron has that kind of warranty on the batteries. Do I think that they're going to fail before that? No, but if you want that great warranty, that may be a reason to use a different brand. So I'll leave it at that. Question number 4 from Dakota says, it doesn't have to be a van, right? I'm applying your techniques and best practices to my enclosed trailer. It's not all apples to apples, but for the most part it is. Anything jump out as completely different when applied to a trailer versus a van? No, for the most part, the trailers are exactly the same. The one thing that I did think of, and I do have students that are building trailers in my course, even though it's called the Van Power Crash Course. I have people renovating old RVs or new RVs, and I also have people with trailers. The one thing that I would say is I use the non-isolated DC to DC chargers to get power off the alternator. If you're going to do that with the trailer and you're going to try to pull power from the alternator of the tow vehicle, you would probably have an isolated DC to DC charger where you have 2 different grounds. And that's because I'll typically have a single ground with the non-isolated chargers, and I have that ground go to the chassis, and that just connects everything. It connects to the vehicle's alternator, and it connects to the rear batteries. It just links everything up. But when you have 2 different chassis, basically the chassis of the trailer and the chassis of the tow vehicle, you can't just tie to a chassis and have it all link and electricity flow. So you would have an isolated DC to DC charger, and one ground would run to the trailer chassis, one ground would run to either the vehicle chassis or the vehicle's battery negative to complete that system. And then you'd probably have Anderson power pole connectors to actually make the positive and negative connection with the tow vehicle, and you would pull those apart and coil them up when you weren't using the trailer. So that's the main difference between a van and a trailer, is you've got the separated chassis and you have to deal with that. Great question. From Richard, he says, for those of us with camper trailers, would it be more cost effective to add additional 12-volt system for additional power when off-grid, or a solar generator? This may require a whole video, but maybe show basic installation for each type. I'm going to make this about the solar generators versus a homemade 12-volt system. The main limitation I see with the solar generators is just capacity. You'll notice that, and I'll say there's a lot of engineering in the solar generators. It's basically an all-in-one with battery capacity, an inverter. You can put power in, you can take power out. It's a power system in a box. And there's quite a bit of engineering and some impressive controls that they've done and the software that runs them. I'm impressed. However, I would say a lot of times the inverter's not big enough to run a stove. The battery capacity is not big enough. Batteries are expensive, and so they're going to try to cut down on that. Even if they're charging you $1,000, $2,000, they're not going to put a lot of battery capacity in there because they're competing on price. The other thing that I've seen is some of the battery cycles. One of the all-in-ones, I'm not going to mention a brand. I'm not sure exactly what brand it was, but it said the batteries will do 500 cycles, but it said we have lithium batteries. Lithium batteries should be 4,000 to maybe 8,000 cycles, maybe 3,000. But when you start talking about 500 cycles, I'm wondering what kind of lithium battery is actually in there. So just the quality of the lithium battery and potentially really the capacity of the lithium battery is not enough. I did have a student, he bought the Goal Zero Yeti 3000 lithium. This was in like 2017, and he really didn't want to get into all the electrical system work that has to be done, which is quite a bit. And he bought their top of the line Yeti, and he's been going to a lot of the national parks. And there came a day when he wanted to have air conditioning, and they tried to get like a little 700 watt air conditioner that you would put in a house, that you would put by the window. And it really just doesn't compare to the rooftop air conditioners. And then if you get a DC air conditioner, it may take 40 amps, but that little all-in-one, it's not built. That's the other limitation. It's not built to put out 40 amps out of one plug. And the other main thing is from the alternator, that is a huge source of charging, especially in off-grid scenarios. And a lot of times it'll take maybe 15 amps at 12 volts. That's like 180 watts. And the systems that my students and I are building are maybe pulling 1,000 watts off of the alternator. And so the limitation is you're not getting, you may take 5 times as long to charge, so you can't really get the power in or the power out at the rate that a full power system would be able to do. So I'll go ahead and leave it at that. Great question. Damien has kind of a long question. So he's got a 4x4 with a 12,000 pound winch, and he has the cables running underneath, I guess by the engine, and he's got a 750 amp fuse running to the winch with a 4-aught cable, and he's afraid that that cable is going to catch on the chassis, and basically will it start a fire or damage something before that 750 amp fuse blows. So what I would say is cables rubbing against the chassis and blowing fuses or creating sparks is really what you'll see with sloppy installers. And I dealt with this at a van shop where I used to work. I'm not going to name the name of the shop, but basically people that they ran cables over transaxles that were spinning, or the spare tire carrier that had a sharp edge, they would run that cable around it. I would say use some split loom to armor your cables, and then if you need to suspend them in space, if you're going through an engine bay and you need to suspend that cable, you can zip tie it this way and zip tie it that way where it's kind of suspended in the air. But basically, if your installation is quality, it should not be rubbing up against other components where it's going to ground out and short circuit. The other thing is, you know, that 750 amp fuse will eventually blow. It may melt part of the cable, or it may melt some steel. That is kind of a higher amperage fuse. But I would just say armor that cable and keep it away from the other components. The other thing you could do is use 2 cables with fuses of half the size and just run 2 positive cables to the winch. If you wanted to do 350 amps and 350 amps with smaller cables, you could do that. But really, you know, winches are a common thing that people install. I would just keep that positive cable away from the frame of the vehicle with armor or zip ties or whatever you have to do to properly install that cable. I hope that answers your question. Let's roll on to question 7 from Mark. He says, this is about battery and disconnect safety. Before even getting into wire and breaker sizing, where should you have disconnects or breakers in your system? Basically everywhere. So you're going to have it on all of your charging sources, solar, shore, and alternator power. And you're going to have it on each circuit that goes out into the van or whatever you're building. So your DC circuits and your AC circuits are going to have fuses and breakers respectively. And then each of the chargers you get they'll tell you in the manual what to add. So for a DC to DC charger picking up alternator power, you're going to have fuses on either end. For solar, you're going to have, I put breakers between the solar panels and the charge controller. I'll have one breaker on the positive, and then from the charge controller positive to the batteries, I'll have another breaker, and I'll consolidate those into one breaker box. Midnight Solar has a good one, the baby box, I think it's called. I just put the two breakers and consolidate that. And then the AC to DC panels, AC-DC distribution panels are going to run your 12 volt and your 120 volt lines, or 230 volt if you're outside North America. But your AC and DC lines can be fused and have breakers added in one box. So basically everything, because anything could short circuit, so each line that needs to be protected, whether it's a consumer line running some appliance or going to a power outlet, or if it's coming off the engine and it's a charge source, all that stuff needs breakers and fuses. Like I said, the manuals will give you a lot of information on what kind of overcurrent protection to use with that particular device. But my answer is everything. Number 8 from Knut. He says, why not make RV electrical install as simple as possible? I think a lot of your work are overkill. Well, I would just say, recommend to me where you think I could cut back. I think a lot of what I show on YouTube is advanced monitoring, like we're showing temperature sensors or water tank gauges. And that does add a lot of complexity to, power systems. But that's the reality of what you're going to end up with, where we could focus just on the power system, but then it's like, oh, well, I've got water tanks over here, or I want to know the temperature of my refrigerator, and we could add that in as an afterthought, but really you're going to run into, especially with the water tanks. Again, the shop where I used to work, they would do the electrical system, and they would put water tanks, and they would try to do it where you could look in on the tank or whatever. And it was really just inappropriate, especially if you have water tanks underneath the vehicle. You need some kind of sensor or gauge to know, how much is left in that tank. So, and the boss over there, the owner, he wanted me to make the electrical systems less complicated. But usually I get that statement from people that don't build electrical systems. No offense, but everyone thinks it can be simpler. I'm like, okay, I try to simplify my systems, but tell me how you want me to simplify it, is what I would say. Where is it too complex? Question number 9 from Dave V. He says, I'm afraid I have more of a technical question. Everyone has a technical question, Dave. If you could do an episode on how to program Victron 100 amp buck boost running on 24 volts, 24 volt alternator, 8 24 volt lithium batteries. Dave, this question, you may need to join my course. I'm going to have to hawk my course a little bit here. I could do an episode on this. The buck boost from Victron, everyone, I get a little flack for featuring so many Victron products. The buck boosts from them are very expensive in my opinion, and I have never featured one. I would have to look in on that. I'm going to go ahead and move on. Maybe contact me, Dave, for more information, or if you really want a lot of help and some diagramming of your system, join my course. So, number 10 from Jeff. He says, tank sensor wiring. Why would my tank sensors all show 100% full all of a sudden? Trailer is less than 1 year old, has the plug type sensors. Working fine one day and then all started showing 100%. It sounds like you have the micro monitor system with the resistive reading. Those, I'm a little bit surprised that they're still using those with the RV manufacturers. They tend to get false readings when you get slime in the systems, especially for the gray water and the black water tanks. You mentioned that maybe the circuit board is not working correctly. The circuit boards for those tend to be less expensive from KIB. You might change out the circuit board. You said that having your sensors gummed up is not the problem because your trailer is so new. So the PC board may be bad, and you may contact the manufacturer of your trailer for that. I have been using the KUS resistive senders and hooking those up to the Servo GX. So I'm not sure completely what's wrong there, but I would try to get a new PC board. Question 11 from Larry. Larry says, why don't you add motorhomes and especially older motorhomes to your DIY videos? There are lots of us who could use assistance with more complex systems which involve crossover switches, starter to house batteries, DC to DC systems, and proper wiring. Between already existing alternator charging to house batteries. Larry, I do have people with older RVs in my course. As far as YouTube, I pretty much make videos that I think people are searching for. I guess this is a topic maybe I can feature in the future. Really what I feature on YouTube is applicable to older RVs. And like I said, some of the students that I've had in my course that have older RVs, one of them was switching to lithium batteries, and he wanted to figure out if he needed to change out the chargers that came with the RV. I believe he had a Winnebago van. And then I had another student with a trailer that came from the days when they did not add solar to these trailers, and he wanted to add solar as kind of a battery maintainer. So we spliced into his existing RV electrical system. So I have those people in my course. Some people want to just get the free videos on YouTube, and that's fine. I may feature videos about this in the future. But honestly, people building new vans are more likely to work with me and buy my programs, and so I tend to kind of veer towards that audience. People that buy really old RVs, maybe I'm kind of oversharing here, but you buy really old RVs, they don't want to pay to work with me. They just want to stay on YouTube. So that's a little bit why I don't cater to that audience. It's just kind of the reality as somebody that creates educational programs. All right, I had to change my camera really quick. Let's go to question 12 here from Ed. Ed is also one of my students. Hey, Ed. He says, I use your training videos when building my solar/lithium system. My system is on a 50 amp Class A RV. Do you plan videos for 50 amp systems? I haven't really touched on 50 amp systems. I typically do 30 amp systems, and that's what I feature in my course. The wiring is really not that much different, and for vans, which is kind of my specialty, I max those out at 30 amps. So 30 amps times 120 volts in North America is 3,600 watts. These vans really are not consuming more than that. So if you plugged into a 30 amp service, it's enough. Typically 50 amp service is when you have 2 air conditioners and you're plugging in at an RV park. I guess that's probably a realm of, again, of the RV industry that I could touch on. But as far as the actual wiring inside the van, for 50 amp, you're going to go from 10 gauge up to 8 gauge. So you go a little bit larger on the cabling. But other than that, the actual wiring diagram would be the same. Even the inverter chargers that I recommend from Victron, they have a 50 amp transfer switch inside there, so they're able to handle that power. It's really mostly the same stuff. Some people like me to show exactly what they're doing in their project, which is hard to do because every project is unique. But I would say there's not a whole lot for me to cover going from 30 amp service to 50 amp service, other than increase the size of your wire and increase the size of your breaker. The rest of the real system design would be the same. So I don't spend a lot of time covering that. So I'll leave it at that. Next up we have Jerry, who says, what's the best way to advertise and sell my 2018 ProMaster? It's pretty loaded. I don't really sell vans. Maybe I'll sell my own van one day. But I would go on one of the van forums where they allow you to post vans. Maybe go on all the forums. I know Sprinter Forum has a subsection for selling your van. So I would go there. That's not really something I can help with. Thanks for the question, though. David says, while operating on battery power, my power strip shows it is not grounded. Is there a way to ground the system? My freezer says it should be grounded at all times. Basically, you have earth ground, which if you plug into shore power, you're going to use that ground. So it's going to flow all the way back to the power pole, and that's going to be an earth ground. If you're unplugged from the power pole, you're grounded to the chassis. It's not really a true earth ground, and it's different. I think your freezer is going to have a little tag on there that's, please make sure it's grounded at all times. Is more of a safety precaution, but plugging into the power pole is earth ground, and once you unplug, you're on chassis ground, and that's different. I'll go ahead and leave it at that. But that is why some of these little ground sensors are going to show that you're not grounded. You're grounded to the chassis. That's the best estimation I can give of why that power strip is saying it's not grounded. You have a chassis ground instead of an earth ground. I'll go ahead and leave it at that. Hopefully that helps. Question 15 from Rick. Rick says, I've enjoyed your Victron episodes, but I'm converting an older Sprinter van for weekend use or short drives rather than full-timing it and living in a warmer area. I've got a small propane generator to run the air conditioner and 2 Bluetti AC 200P self-contained solar, shore power, and charging. May put 1 solar panel on the roof, did not want the big battery bank. I like your video on the inverter charger and the Bluetooth and the servo. Not sure what I really need to do this. I could plug directly into shore power when available and use the Bluetti to run all 12 volt DC and occasional cooking. Water pumps. This is a really long question. Without running the propane generator. Not sure if all the Victron equipment is needed or some old monitors, tanks, propane, and water would be easier. I'll say this. So it sounds like you have the Bluetti all-in-ones. You've got a pair of them, it sounds like. And you're wondering if you need the full power system with the Victron equipment. I would say the propane is going to help you a lot. The propane generator, you can run the generator and you can also cook directly with propane. And those are your biggest loads. You mentioned a 120 volt AC. I would just say your propane can handle a lot of your larger loads, either via the generator or cooking. However, the Bluettis are probably going to max out. They're going to run your electronics like your laptops and your phones. So I would say you would typically be limited. The propane's going to kind of augment what the Bluettis can do and take some of those larger loads. But I'll reference the question I had earlier with the all-in-ones. A lot of times they are great and they have a lot of engineering in there, but they're not really going to handle the larger loads. So in a way, you've kind of had to supplement with the propane and the generator because the Bluettis can't handle the larger loads. And so you've kind of had to make a workaround anyway. I would say just stick with what you have, but this is kind of a warning to others that want to use the all-in-ones. You're going to end up having to create a workaround, or you're just going to have limitations on what you can run. I'll leave it at that. Jan says, Dear Ross, on the boat I just purchased, I have 3 lead acid, 230 amp hour batteries for service. People advise me to wait a few more years to switch to lithium. Reason, dependability, and capacity will go up and prices will go down big time. I was told even to consider gel batteries as an intermediate if my current ones give up next year. Please share your thoughts on this one. I would say the price decrease on lithium has already happened. In 2017, 2018, there weren't that many options on the market. They were extremely expensive. The lithium prices have dropped quite a bit. Maybe not from Victron, but there's just been a proliferation of manufacturers of the batteries, and some of them are a fraction of the kind of name brand batteries. I would be cautious going super cheap on the lithium, but because your battery management system is going to be super cheap in there, and you don't want that. But I don't know. I wouldn't wait for the price to drop. If you have existing lead acid batteries, I would go ahead and leave them until they fail. But as far as dependability of lithium and price drops, to me that's already happened. So that's my take on that. As far as the gel as an intermediate technology, so gel batteries for everyone listening would be another type of lead acid. I would value your installation labor. I think that's something that people overlook. They're like, I'm just going to build part of my power system right now, or I'm just going to throw in these batteries temporarily. If you go to a van shop, your labor cost is just as high as your equipment costs. You know, think like $10,000 and $10,000, $20,000 for a power system. People always think their labor is free. It's a pain to change your batteries, especially if your battery footprint changes, and then all your battery structure, your hold downs has to change. So I wouldn't take this casually. You know, I would put in what's mostly going to be a permanent solution. Lithium oftentimes will outlast the vehicle that you put it in, or in your case, the boat. But that's my take. I would not go to gel. I would run those lead acid batteries until they're dead, and then I would get the best lithium option that you can find at that time. So I hope that helps. We've got question 17 from Bruce. Bruce says, when I retired a few years ago, I saw many van conversion postings on Pinterest, which inspired me to convert my 2009 Ford E150 into a stealth camper. Your van was one of them that I liked. Thanks for saying that. I liked how you built an off-grid van that allowed you to travel to cool places. My wife and I have traveled around the western U.S. One of the coolest free campsites we found was when we crossed the Golden Gate Bridge and camped for the night on the northern end of the bridge viewpoint. I've actually been there. That was a really cool area. The view of San Francisco skyline at night across the bay was unique and spectacular. Yeah, it's a beautiful place, beautiful city. It was something we enjoyed very much. What are some of the unique, spectacular views you have seen from your van, and how do we get there? The place that sticks out in my mind, well, first one would be Big Sur, California, Bixby Bridge on Highway 1. I actually had that as a screensaver before I took off in my van, and that was kind of my inspiration for leaving my corporate job and getting into the van and traveling. So Bixby Bridge on Big Sur Coast was phenomenal. Big Sur definitely lived up. Big Sur is odd because it's a very desolate area of California in the United States, our most populous state. But the whole central coast is just desolate. There's not any major cities or lots of people. So it's kind of odd to be in this state with so many people, but have these pristine, beautiful areas where there's not very many people. So Big Sur was amazing. The other place that I really enjoyed was the Sonoran Desert National Monument southwest of Phoenix, Arizona. I was able to drive about 6 miles off the highway and have my own campsite, and I really had my own mountain valley. And if you go out there in January or February, the snakes and scorpions are all sleeping or hibernating, so you can walk around, you just see deer, and there's the giant saguaro cactuses. That was another magical place. I went out there every weekend when I was staying in Phoenix. So Big Sur and Sonoran Desert National Monument, I would say, are awesome. Thanks for the question, Bruce. Next up, we have David. He says, after being connected to shore power for a while, why do my batteries show state of charge dropping to now 0? I'm going to need more details on that one. Some of these questions, I'm pretty good at power systems, but I still need to know, what your components are and how it's wired. Some of these I can't. Some of them I get off the top of my head, but others I can't. So I would say I'm going to need more information on that, David. Thanks for the question, though. Kenny says, when connecting a remote starter button, where do I plug it into? I want to have it so the button would only crank the motor when the ignition is in the on position. Kenny, I got to be really honest with you. I know how to set off relays to start the engine, but as far as tying into the engine, I would go to an automotive shop that does that. I have not actually done that particular thing. I know you can start the engine off of a 12-volt relay in the back, but as far as the technicalities of starting the engine only when the ignition is turned and stuff like that, an automotive shop would be able to tell you. So, sorry. Next one is from Alex. He says, hi Ross, love your videos, thanks. I live on a yacht and have installed Victron systems throughout, partly with your input helping with my installs. I don't have any particular question, just wanted to say thanks. However, I have a 3 amp drain coming from somewhere, just need to find it. I enjoy the tech part of your videos, please keep up the good work. I guess the question would be, what are your preferences for connectors and what tools do you especially like? So we actually got 3 questions here. The 3 amp drain, what I would do is disconnect things and basically keep an eye on that 3 amp drain until it goes away. So you could pull your fuses on your 12 volt devices and basically keep an eye on that drain and try to isolate it. So anytime you're troubleshooting, you would just try to isolate, find which circuit is the problem. And so you would just basically remove circuits by pulling their fuses until you figure out the circuit that it has that 3 amp drain. And on your other questions as far as connectors, recently I found the Hystronica butt splices that I really like on Amazon. I'm able to hit them with the heat and heat shrink them, and they don't actually, a lot of the brands, the heat shrink kind of splits, and so it exposes the metal underneath. The Hystronica doesn't seem to do that, so I like those connectors. And then the tools I especially like for electrical systems, I like the Timco hydraulic crimpers. I've said this on YouTube, and everyone wants to use the hammer crimpers. I've gotten a lot of flack because I don't use the hammer crimpers, which are admittedly a lot cheaper, but I really like the hydraulic crimp because, having poor crimps is where you have loose wires and things can heat up and problems can occur. Oxidation of the wire can occur. So I really like good crimps, and I like the Timco hydraulic crimpers. Thanks for the questions. Moving on. David says, is there a conversion from deep cycle batteries to lithium that can be done in a simple fashion, and what is the benefits other than weight reduction? I suppose the second part of the question is amp hours gain with lithium. Yeah, so amp hours gain, you're going to be able to use the entire battery capacity. We said weight reduction, that's another one. The other thing is speed of charging. Lead acid batteries take too long to charge. You might be able to bulk charge them up to 80%, but then they want you to kind of baby them and trickle charge them for hours. And lithium batteries in a van, it's the same as the lithium battery in your cell phone. You can plug it in for an hour and it's charged, you're done. Lead acid, nobody has that kind of time. And then lead acid, they want you to be charged up to 100% all the time so they don't have sulfation on the inside, which I basically refer to as corrosion on the inside. And your batteries, having them brought up to 100% all the time isn't always realistic out on the road when you're camping. The lithium batteries actually do better if you don't take them to 100%. You keep them maybe up to 80%. So just usable capacity, weight, the number of cycles, longevity. There are many benefits to lithium, And I would say the fact that I'm not getting that many questions about lead acid batteries, or if people should buy them for a new build. I used to have a lot of people do brand new electrical systems and they would put in lead acid, and people are not doing that anymore because the lithium does have quite a few advantages. Next question from Dan. Hello Ross, I would like to know if I can jumper off of my Victron Orion TR Smart isolated DC to DC charger cables coming from the starter battery to my Victron Smart Shunt so I can see the starting battery voltage level with the Victron Connect app. So you basically want to hop onto the wire that's going to the DC to DC charger to pick up that voltage. I would say yes, you can do that. So for everybody listening, the Smart Shunt will monitor your rear batteries, but you can use, it's got a second input where you can monitor your starter battery as well. So he wants to, instead of running that wire all the way to the starter battery, he wants to jump onto a cable that's coming from the starter battery. So I would say this, Dan, you can, I think Dan is one of my students as well. Hey, Dan. You can hop onto that cable that's coming from the starter battery, the battery positive going into your Orion charger. But your battery voltage reading is going to be accurate when the engine is off and nothing is flowing through that cable. You're going to get an accurate reading, that's fine. Once you start the engine and you're sending 30 amps through that little 6-gauge cable, the voltage reading is going to become distorted. So that's kind of the drawback of doing that and not going all the way to the engine battery. Once you run a lot of current through a cable, the voltage reading of that cable is going to be distorted. So it'll work when the engine is off. If that works for you, I would do it. Hope that helps. Next up from Mick, what is your preferred wire connectors? Is there any value in soldering some of the larger connectors? On the preferred wire connectors, I'll go back to the Hystronica butt splices and small wire connectors that I mentioned in a previous question. Been enjoying that brand lately. As far as soldering some of the larger connectors, I would say if you use a hydraulic crimper, it's really going to eliminate a lot of the air gaps between the conductors, and it's going to crush the conductors together, all the little wires in your welding cable. It's really going to eliminate any gaps if you have a good hydraulic crimper, and that's another reason why I'm not really satisfied with the hammer crimpers, because you're not eliminating all of those gaps. When you hit it with 11 tons of pressure, you eliminate a lot of gaps. I would say I think the soldering would increase the conductivity there at the connector, but you're really wanting to reduce the resistance in the cable. I would say a lot of times reducing the resistance in the overall cable, you would just increase the size of the cable. But if for a given size of cable, soldering that connection, yes, it would reduce the friction in that line by a little bit. As far as the efficiency gains, I can't say how much. I think it would help slightly. But in general, if you want to reduce the friction in the line, increase the size of the line. So I hope that helps. Thanks for the question, Mick. Next one from Robert. Can you connect the Inverter AC Output Earth, an earth leakage breaker, to the vehicle chassis that runs the 12-volt DC negative, or should the AC earth and DC negative be kept separate? I will combine them. Not completely sure what this is asking. The AC outputs earth. Okay, so the output from the inverter, that ground, let's see. So you would ground the inverter to the 12-volt DC negative, which is going to be grounded to the chassis. You're not going to ground the output, like the green wire, the ground wire output from the inverter. You're not going to ground that to the chassis. No, you're going to ground the inverter itself to the 12-volt DC negative, and that's going to be grounded to the chassis. So I hope that answers that question. Next from Keith. Why did you get into van living? Are you still living in your van? So I'll say first, I'm not living in my van, mainly because I was not able to produce the number of videos, like technical trainings that I needed to produce. I lived in a van for 2.5 years from 2016 to late 2018. The reason I got into van living was because I was fed up with my apartment and my 9-to-5 job. I had never left my hometown of Houston, and I just needed some way to break out and kind of pattern interrupt my life, what I was doing. And it really did that. And that's a big reason why I still teach this and I still encourage people to build vans, is because it was a way for me to kind of escape a very prescribed life. And I was not happy with what I was doing, but I kind of had golden handcuffs with my job, and everything was stable and safe. You know, I knew my neighborhood, I knew where everything was. A lot of times exploring new cities and exploring new areas of the country, you don't feel as safe or secure. You don't know where you are or where you're going. So exploration out there is thrilling, but it takes a certain amount of guts to get out of your routine and chase your dreams. And so that's really what the whole van thing was for me, was breaking out of the monotony and facing some fears and kind of growing as a person beyond what I was staying in my hometown. Great question, Keith. Thanks for asking that. All right, we got question number 26 from Fabio. He says, I have 3 solar panels, 200 watts each, total 600 watts, 3 lithium battle-borne batteries, 12 volt, 100 amp hours each, also an MPPT 100/50. My question is, what is the best way to connect them, series or parallel? He wants to connect the panels in series and the batteries in series, but he's not sure. All right, so on your batteries, if you connect those in series with battle-borne, you can do that. But it's going to create a 36 volt battery system. So you're going to have a 36 volt inverter charger. I'm not sure if you're wanting to do that. I would guess you're trying to keep a 12 volt system. And so in that case, I would do the batteries in parallel to maintain them as a 12 volt 300 amp hour battery bank. The solar panels are a little bit different. So basically, the rule of thumb is you want to do 3 to 4 times the voltage of your batteries coming out of your solar panels. So what that would look like is a 12 volt battery bank would have solar panels that are sending 36 volts to 48 volts to them. One of the reasons that you want to do this is because when the sun comes up in the morning, basically as the sun gets higher in the sky, the voltage of your solar array is rising. And let's say that your solar panels are 20 volts each. You didn't list that, so I'm not sure what the voltage of each panel is. But let's say they're 20 volts each. If you wired those solar panels in parallel, the output of that system would be 20 volts. And it may take till 11 a.m. to get them to their peak voltage. The issue with that is a lot of the charge controllers, such as, it sounds like you have a Victron charge controller, that's going to require the solar voltage to be 5 volts above the battery voltage before it kicks on in the morning. And so your 12 volt batteries will probably be 13.2 volts in the morning. And so your solar array has to get to 18.2 before that charge controller starts sending power through from your solar panels. And so that can also occur at the other end of the day at sunset. That voltage of your solar panels is going to begin to drop. Now, in that case, it only has to be 1 volt above your battery voltage for the solar charger to stay on. But in the morning, you may lose a couple hours of solar production as you're waiting for that voltage to rise to 20 volts. So if you could, I would aim for anywhere between 36 and 48 volts out of your solar array. If these panels that you have, these 200 watt panels are, say 30 volts output or 35 volts output, I would just wire them all in parallel and it'll spit out 35 volts as your solar array voltage. So 36 to 48 volt, wire those batteries in parallel if you're going to maintain a 12 volt battery system. So hopefully that answers your question. Next up, we have Duane. Duane says, Ross, I really enjoy your content, so please continue. I'm definitely planning on continue. I appreciate that, Duane. His question is, we install large battery systems so customers can run their AC all night from 10 to 15 kilowatt hours in a future project for 20 kilowatt hours. At what point would you recommend that they move from 12 volt to either 24 volt or 48 volt? I know there are many options on the matter, starting with always 12 volts, so I'm interested in hearing your opinion. Keep up the great work. So this is actually something I've been looking into recently. The biggest difference is going to be charge rate, because when you look at watts, it's a product of voltage and amperage. When you multiply the voltage, you drop the amperage. And a lot of the limitation of this equipment is how many amps it can take at one time. And so to me, it would just be charge rate. Now with the lithium batteries, they can take a lot of amperage to charge them. They can charge really quickly. But I would say as you increase their voltage to get the same number of watts, for instance, if you go from a 12 volt battery system, 100 amps, right? Well, if that's 1200 watts. If you go to a 48 volt battery system at 100 amp, that's 4,800 watts. So it's 4 times the wattage actually being absorbed by the battery bank. But you're still at just 100 amps. So if you have an amperage limitation, now your charge source has to be able to put out 4,800 watts. But I would say, like a lot of the electric cars, the super fast charging stations for like a Tesla, they're not running a 12 volt system. I believe the Tesla is 24 volts. But as you're basically able to put more watts in there as you increase the voltage of the batteries. But I would just say for everyone listening to this, oftentimes the 12 volt battery banks, they're going to max out the charger that you connect to them. Like basically, you may only be able to get 1,500 watts from the power outlet that you plug into. So you're not going to be able to get 6,000 watts unless you have a special power pole that you're plugging into. So sometimes the limitation is not how much your system can absorb. The limitation is how much power your source that you're plugging into can put out. So hopefully that answers your question, Duane. That was a good question. So more to come on changing your battery voltage to 24 and 48 volts. Nikolay says, what type of wiring is required for DC to DC charging? That would typically be welding cables. The size of the cable depends on the DC to DC charger that you get. They're going to tell you what size cable to use and the fuses that they want. Fuses or breakers, what the current rating would be for those fuses or breakers. So a lot of that's going to be in the manual. But I would say welding cable with very fine strands would be the kind of my standard answer for that. Dan S says, with two 12 volt batteries in series and a Victron Smart Shunt and a Watts 247 balancer, does this all work together? Victron says to have nothing else attached to the output battery minus. I'm guessing that the balancer that you have it's connected to both batteries. I did look this up previously. I haven't used that device, but the balancer is connected to both 12 volt batteries. Basically, with the Smart Shunt, it's the one gateway to battery negative. If you bypass it and connect anything else to battery negative, that will not be measured. You're giving it an alternate path. It has to be the only way in and the only way out to battery negative in order to get an accurate measurement. So if you break that rule, then the Smart Shunt is going to be taking a measurement of anything connected to it, but it's not going to capture whatever lines bypass it. So the calculation will not really be as accurate. So hopefully that answers your question. Great question, Dan. Michael says, if solar panels are series connected for 24 volts feeding a Renogy 60 amp MPPT, do I have to have a 24 volt battery bank, or will the controller step 24 volts down to 12 volt for 12 volt batteries? Definitely, yes. Your solar charge controller is there to step down that voltage, and you do not want them to be at the same voltage. Your solar panel voltage must be higher than your battery voltage, because like I said, it's like water tanks. The different batteries being water tanks, we could think of the solar and the battery being different water tanks. That solar panel voltage has to be higher than the battery voltage so that power can flow. It's like an air pump. You basically need a higher pressure over here to pump up that battery. If they're at the same pressure, or the solar panels are at a lower voltage or pressure, essentially, it's not going to be able to pump up that battery. So it has to be higher, and your solar charge controller will regulate that voltage down to the battery voltage. So great question, Michael. Next up from Anonymous, when using a shunt or not, do you ground your house batteries to the chassis? And if so, how do you ground them with the shunt? So basically the shunt would be like a smart shunt or a battery monitor. Battery negative is going to run through the shunt, and then that's going to connect to system negative, and system negative would be a bus bar, and then that's grounded to the chassis. So the connection from battery negative to system negative has the shunt in there, and there are no ground wires in that circuit. So hopefully that answers your question. Next up, from Anonymous, I'm going to have to skip this one because they didn't put their name, and that question is so massive. I can't. I'm sorry. I'm trying to read these quickly. Keep it entertaining here. Tom, why do most van builders run all DC negative wires back to the fuse block versus just grounding to the van chassis? Well, first, Tom, I would say that you could ground them to the chassis and that would work, and that's kind of how the vehicle manufacturers do it. You'll notice for the tail lights on a van and everything, they are grounded to the chassis, and then all the negative, all that connection back to the vehicle battery is run through the vehicle's frame. I would say if you're in a production scenario where you're producing lots of RVs, I did take apart an RV out of Canada, the Pleasure Way. It was a Sprinter, and they played all sorts of games with the negative and consolidating the negatives and into a big trunk line, and they did all sorts of things to save wire and stuff like that. For the most part, it's just if you're building a single van, a lot of times your positive and negative are going to be in a single jacket, and you're just going to run them back to the fuse block. Taking that negative out of there and trying to hop it onto the frame. One, you're going to have tons of connections to the frame. You could have corrosion because it needs to be metal on metal. So you have copper on steel. You got to remove the paint to get a good connection there. I think running back to the fuse block with your negative is often the easier way to do it, and possibly more reliable if we talk about introducing corrosion on that chassis ground. You got to scrape away the paint, connect it, and then I like to repaint over the connection to prevent corrosion. So you've got a lot of corrosion issues there, and you'd have a lot of connections to the chassis all over the van. So like I said, the vehicle manufacturers do that. I suppose that you could do that, and you could just connect your system negative to the chassis, and you could use their chassis bolts, and it would flow back to your system negative. But I don't know. It's kind of a personal take on whether you want to do that. But hopefully that gives you some food for thought on that. Next up from Eric, is there a video or source for a simple system that is not going to need or have installed solar panels? Our vehicle is never going to be used off grid. 120 volt shore power will always be available. Yes, so it doesn't sound like you need batteries either, really. You would just need a shore power line coming in, and you could use a converter that would step down the 120 volts to 12 volts, and you could connect that to a 12 volt fuse block. If it's plugged in 24/7, basically the converter would feed the fuse block, and then your 120 volt line would feed a breaker panel, and then you'd have your branch lines coming out from there. Just don't install solar. The way that I teach this is that, you know, solar and alternator and shore power, they all tie in to system and positive and negative, and that feeds your batteries. And if you don't want that charge source, you just eliminate it. It doesn't change any other charging sources. They all combine on system positive and negative, and if you eliminate solar, that doesn't affect the alternator charging or anything. So if you don't want solar, just don't install it. But hopefully what I said at the beginning will help you. Just bring in that line, and you probably need a converter if you have 12 volt devices. If you don't, then bring your line in to a breaker panel. You'll have a main, probably 30 amp breaker, and then you just have your branch breakers and just run your branch lines to your outlets or whatever you are trying to power. So hopefully that helps. Jay says, how can I get advanced Victron training? I've watched all the videos and my rep doesn't want to give me his contact at Victron. I have a vendor account through them and they just resell to me with little technical support. I'd like to learn more. You can go to professional.victron.com and they have training videos. They have video courses on a lot of their stuff. And then I signed up here in Houston for a workshop in January. They have an in-person workshop, and they have these all over. They have workshops in Germany, France, the Netherlands, the United States, various places. So you can do in-person training, and it's free. I think you have to sign up for a professional account, but I definitely, it's better to play around with this equipment and know it yourself than have someone that you can call, especially if you're getting to that level, because whoever your contact, your rep is, I don't know, some of these people are busy and they don't have time to answer your questions, so it's better if you study it and you can answer your own questions. So I agree with what you're doing. Go to professional.victron.com and see what you can find there. Russell says two things. My servo doesn't show battery percentage charged. Voltage is shown. Second, my monitor is not available on the app. He's got a Newmar Dutch Star with the Victron inverter charger and the Servo GX. So it sounds like your smart shunt or whatever battery monitor they put in there is not plugged in. The plug may be loose at the battery monitor or at the Servo GX, but basically I tried this on my Servo the other day. I pulled the battery monitor cord, and the percentage shown on the battery on the Servo went away, and it just showed the battery voltage. So the Servo may be able to bring in battery voltage on its own because it's connected to the batteries, but that percentage is only going to be coming from your battery monitor. So just make sure your battery monitor is operational and is plugged in to the Servo and at the battery monitor. If you can't pick up the battery monitor on the phone app, the battery monitor may be dead. It may not be working. It's got a little inline fuse on the positive line. I would open and check that fuse. It may not be powered up at all, and that may be why it's not showing up on the Servo and you're not able to pull it up on your phone. So hopefully that helps you. Great question, Russell. Number 37, Colton. What way do you believe is the most cost-effective and safest setup for your batteries and vehicle to charge off the alternator in a Sprinter van? Components and CBs. I'm assuming that's circuit breakers. So in a Sprinter van, it depends on the model. Before, up to 2018, they didn't want you to pull more than 40 amps off of the alternator. And so in that case, I would use a Victron Orion non-isolated charger, pull 30 amps. It's going to take 60 amp fuses on either end of the line. You could change that for 60 amp circuit breakers. The later sprinters, as far as the manuals show, from 2019 onward, they don't give a amperage limitation that I've seen. Somebody's going to catch me on this. But I put 60 amps on those. So I'll put 2 Orions. Sterling has a new 70 amp that's coming out. The Sterlings are starting to have bi-directional charging. So question number 1 from Carol, she asked about charging her engine battery when her van is sitting there. Bi-directional charging will do that, where your solar panels charge your rear system and then it trickle charges your engine battery. So the bi-directional chargers are definitely something to look into. So Sterling has a 70 amp that they're selling out of the UK right now. You might look at that one. That is going to tell you the cable size to use and the circuit breaker size that they want, which is the case with all these chargers. Whatever charger you buy, whatever amperage you buy, look in the manual for the circuit breakers and the cable size, because there's no standard answer on that. But yeah, if your Sprinter's 2018 or before, cap it at 30 amps, do the Orion. If it's 2019 and after, maybe do 2 Orions for a 60 amp or the Sterling at 70 amp. Personally, from an old Sprinter, from a 2016, we put a relay on one of those, and there were times when it was pulling over 100 amps. So the Mercedes, they're cautious, they're conservative on what their alternators will put out. But oftentimes they have a very heavy-duty alternator, and you know, you could probably pull over 100 amps off of it, and it's going to violate your warranty. But you could probably do 60 amps safely, regardless of what model you have. Edwin from the Netherlands says, I have 2 questions. Our camper, we use Orion to charge the camper battery. Outside of the van, there are spotlights that connect to the starter battery. We use them for driving in the dark when we arrive at our campsite. We also, when we camp. How can we detect when the starter battery is too low, and how can we charge it on our shore power and off-grid? Well, just like the last question, you could get a charger that has bi-directional charging, or you can go back to question number 1, where I told Carol to put a switch, a bypass switch underneath your Orion. So the incoming line to your Orion goes through one side of the switch and then up into the Orion, and the outgoing line to the Orion goes to the other side of the switch and then out to your rear system positive. And you just turn on that switch when you want the power to bypass the charger and flow up to your engine battery. But the real solution here would be to get those loads off of your engine battery. You can run your loads off of your rear battery bank. Even if they're ignition controlled, you can get the power wire to the rear battery bank and then run the ignition wire to the vehicle. But in general, you know, loads like lights and stuff like that, they shouldn't be on your engine battery. Your engine battery should only start the engine, and try not to put anything else on it, is what I would say. So hopefully that helps. Question number 2, is there a way to control the appliance like the water system or the heating or ventilation from the Victron system? You can. So if you have something like the Serbo GX or some of the Victron battery monitors, they have a little relay. So those relays, if you could program them based on temperature, like I covered the Ruby sensors a couple videos ago, you could have that relay set off when the Ruby sensor gets to a certain temperature. The relay will just connect, and whatever's connected to it will turn on. So you could have your vent fan turn on at a certain temperature. The water system, I'm not completely sure. There is a way to manually turn on the relay. So if you wanted to turn on like your water pump with the relay on the Serbo GX, you could manually you could hit the screen and say turn on relay, and it would turn on the water pump. But if it's not automated, I would just have a water pump switch that you can easily get to rather than having to go through the Serbo GX screen. But yeah, you would just program the relays I would get in the Servo GX and look at what type of things can set off the relays and see if that works for your application. Hopefully that helps. Thanks, Edwin. Susan says, hi Ross, thanks for your awesome video series, well worth the money. Thanks for being a student, Susan. Any tips for safe and fun travel with cats? Yes, I would mainly say your heating and cooling. You're going to want to worry about those. I would, for cooling especially, I think in the cold the cats can kind of curl up, but with the cooling you want to have a 12-volt air conditioner. And they all have thermostats, so you can have it at a thermostat setting and it'll turn itself on and off. But the 12-volt air conditioner is going to run in off-grid scenarios directly off of your batteries. And especially if these vehicles are not white and they're a darker color, you know, there can be 20 degrees difference between a white van and a black van in the midday sun. And it's a tin can, and you don't want to bake in there. So I would just say watch the heat for those cats, and I would get a 12-volt air conditioner from like the King Tech KTD3, the RTX 2000 from Dometic, and then I've been looking more at Pneumatic Cooling, has some good units as well. But there are a lot of good options on the 12-volt air conditioner, but I would just say in general you want to get one and go ahead and invest in that for those cats. Great question, Susan. Bob says, I have a Victron Multiplus 2, 31,120. I've had the state of charge reading reset to 100% twice. First time when the pedestal breaker tripped and overloaded the Multiplus, and the second time when we moved our camper across the campground while boondocking. Is there a way to correct this? A lot of times on the state of charge reading, it's because it's not properly set up. Sometimes there's a setting that says reset to 100% at startup. And basically if the system turns off and turns back on, it'll just recalibrate to 100%, which is the percentage you said. So with the Multiplus 2, I would get the MK3 to USB dongle and go into that Multiplus on your laptop. You're going to need a PC laptop right now. You can't use an Apple computer at this time. Get the Victron Connect app on your computer, or you can get the VE Configure software on your computer as well. I think the Victron Connect app will work on Apple. I could be wrong on that, but basically get into the programming of that Multiplus and check the state of charge settings. The other thing I would say is for your state of charge on your batteries, I would do that with the battery monitor. Typically, you're only going to use the state of charge off of a Multiplus if it's the only charge source. If 100% of your power is coming in and out of that Multiplus, your loads as well as your charge source, let it be your battery monitor. But if you have any other charging sources, get a standalone battery monitor. Hopefully that answered your question. I know these systems can be frustratingly complex, but hopefully that gave you some insights. Laura says, hey Ross, thanks for what you do. Your info has been a godsend to me. Awesome, Laura. Thank you. I'm in the process of a conversion, and my van will have 400 watt solar, 40 amp MPPT charge controller, and I will also have a DC to DC 40 amp charger to supplement the solar, 200 amp hours of lithium. I'll have a 2000 watt inverter to run a few AC items. I would like to be able to charge via shore power when that's available, but I'm unclear on the additional components I will need for that. If I should only be used to charge the house battery, or if it could also run directly to the AC outlets in some way. I assume in that scenario I would need a switch to engage the AC source. So basically, Laura, you need an inverter charger. I did a video on this on how to add a transfer switch. It's called How to Add Shore Power. And you would add a transfer switch and you would add a standalone charger, and it's somewhat automated The only thing that's not automated is when you plug into shore power, your inverter doesn't turn off. So you would have to still turn it off. It's a little bit hokey nowadays. I would use the inverter chargers. If you want a real seamless system where you plug into the power grid and your inverter shuts down and then the charger turns on and everything. If you watch my video, Add Shore Power, it'll show you how to use your inverter and a transfer switch and a charger. Or you could sell that inverter on eBay and you could buy an inverter charger and it will all seamlessly operate. And then the wiring diagram for that inverter charger would kind of show you how to set it up. You're probably going to want to put a 30 amp breaker and a 10 gauge line going out to the power pole. But that's what I would say. Either get an inverter charger to do what you're trying to do or watch that video on adding shore power to an existing system. So great question. Thank you. Let's roll on to the next one. All right, I had to take a quick break. Let's go with question number 42, Russ from the UK. Can you go into more detail about setting up the Victron Smart Shunt for lithium batteries, please? Basically, just connect to the Smart Shunt with your phone and go into the Victron Connect app, select the lithium battery preset. That's mainly what you have to do. Efficiency is typically 99%. The Pukert exponent, I would look that up in the Victron manual. But there's a preset for lithium in there, especially if you're using Victron lithium. And then I would just say your reset to 100%, get that tail current down to 3% and 3% of battery capacity. And that's about all the settings that I can remember. If you want more help on this, I did a video on the Smart Shunt and the BMV 712. And there's a part of the video where I go into programming it with the Victron Connect app. So I would check that out. But thanks for the question, Russ. Ted says, how do you address the use of lithium batteries in cold weather where the van is used once or twice a month, but is otherwise stored in below zero weather? Lithium batteries can be stored down to, I believe, like -40. It's really when you're charging and discharging them where you have to watch the temperatures. But as far as storage, if you're going to shut down your system, they can go way below 0 Fahrenheit. And the other thing about using them in cold weather where you're charging them and discharging them, they will typically discharge down to 4 below 0, -4 Fahrenheit. And as far as charging them, you need to heat them up. One thing that people don't look at is when you discharge the batteries, that will heat them up a little bit to some degree. So you could just use the batteries and they may heat up to the point where they're chargeable. So that's kind of a tip there. But in general, if you're in a cold place, get heated batteries, which are on the market now from Battleborn. And even if you have regular lithium batteries, you can stick a heating pad on there. The heating pads have a built-in thermostat, and you can just run those to a switch. They're 12-volt heating pads. Facon makes those, F-A-C-O-N. They have them on Amazon. They say they're for water tanks, but I know that you can use them for batteries. I think they just don't want to put that on their disclaimer because they're afraid of liability with the batteries. But yeah, those are some tips that I would use. But as far as storage, they can go way below 0. You just can't utilize them at that temperature. Let me check my mic, make sure it's good. Yep, we're running. All right, I hope that answers your question, Ted. James says, could you talk about how to select the right fuses for different applications and share the pros and cons of A&L versus circuit breakers? And any tips on choosing quality parts? Specifically, are cheap Chinese parts on Amazon worth it? Or are there better parts to look for? Thanks. Great videos, not nerdy. I prefer how-why videos over just how to do videos. Keep it up. Thanks, James. As far as Overcurrent protection, breakers and fuses. No, I would not use the cheap Chinese parts on Amazon. I would get Bluetti systems. They're out of Washington State here in the U.S. I would use their DC breakers and their A&L fuses. Now their fuses are made in Mexico. They're not made in the United States, but I would stick with Bluetti systems. I have had the cheap breakers on Amazon's where they didn't hit their current rating. They were supposed to be 100 amps, but I didn't feel like they were getting up to that. They were tripping, and now maybe my system design at that time was surging over 100 amps unbeknownst to me, but as I would not trust them as far as, I mean, you're basically playing with fire, literally. If these things fail, your stuff's going to catch on fire. So circuit breakers are one area that I would not play around. I would not try to get discounts. I would not I would not try to save money on circuit breakers or fuses. So Bluetti systems, of course, on your 12 volt DC fuse block, they're going to be ATC fuses. Bluetti makes some of those, but you can also go with Little Fuse. Little Fuse is a trustworthy brand as well. But as far as A&L fuses versus circuit breakers, they're going to do the same job. The circuit breakers are really, they're just resettable fuses. And it's also a cutoff switch. I do this with the solar. I don't use fuses on the solar. You can fuse them up on the roof and then the line comes in. It's like, well, how do you shut down solar when you want to work on the system? So I'll have a breaker there, but that's my cutoff switch too. So I would go with circuit breakers where you want to be able to cut that line off for whatever reason. Now, I wouldn't use it as my everyday light switch or whatever. You want to have a regular switch for the circuit that runs the lights. But the circuit breakers are basically a fuse that's operable and resettable. But things that are not going to blow, like your batteries, if you want to have a 400 amp fuse on your main fuse coming from your batteries into the rest of the system, I would use an A&L fuse there. There's so many fuses as far as the trip speed. Some of the fuses, they'll let you go over their rated current, like over 400 amps for a short duration, so that if you have a short surge, it's not going to blow the fuse or trip the breaker. So some of the fuses are slow blow, whereas the breaker might trip right away. There could be some reasons like that to use the fuses instead of the breakers. And also just cost. Your circuit breakers are typically going to cost a lot more, especially if they're quality from Bluetti. I think those breakers are like $30. Now, their fuses are $20. So basically use the circuit breakers where you want to be able to reset if it goes over its current rating, or you want to be able to cut off that line and you need a cutoff switch and overcurrent protection in one device. In that case, I would get the breaker. So hopefully that answered your question. Great question. Jeff says, I've read that modern alternators vary output voltages, so an isolator may not always register that the vehicle is running, or after it's been running a while, the voltage drops when the battery is charged. This could stop your DC to DC charging even though the engine is running. So when you say isolator, I'm thinking of the old relays, and they were very sensitive, like 13.5 volts was their threshold. So it's the smart alternators that you're talking about. They do this to save fuel. When that high voltage output is not needed, it'll drop. Pretty much all the DC to DC chargers now that I recommend, I don't recommend isolators or relays. Go with the DC to DC charger, and they all have accounted for the smart alternators. Victron has a smart alternator setting. Sterling has a smart alternator setting. I haven't spent a whole lot of time with the Renogy chargers, but they should have a smart alternator setting, because this is standard protocol in a lot of cars for their alternator voltage to drop, and it's something that has been designed into these DC to DC chargers. Now, if you go with the relays, they still sell them. They still work great. I don't use them, but they will cut off. If that alternator drops its voltage, that relay is going to open the line and the charging is going to stop. But I don't recommend you use relays anyway, but the DC to DC chargers should have this covered. But great question, Jeff. Rob says, if I don't have permanent solar panels but want to use portable solar panels to top up the van every so often using shore power connection, do I need an MPPT? I don't know how the shore power connection ties in with the solar panels. In general, you do need an MPPT anytime you have solar panels because their voltage is going to be way above the battery voltage, and you need the solar charger. The MPPT is going to be the intermediary that brings that solar panel voltage down to the battery voltage. So you're always going to need that. I'm not sure if you're trying to run that through some kind of solar inlet or shore power inlet, but in general, you do need the MPPT. And just my general advice on the portable solar panels, it just seems like a pain. It's one more thing you have to set up and break down at the end of your camping trip. I would just bolt a solar panel to the roof. If the thing gets shaded at your campground, then what you could do is have enough battery capacity to carry you so that you can park in the shade and not worry about it. Let that solar panel run while you're going down the road, which consequentially is not going to be something that you'll have if you have the portable solar panels. All that time you spend on the highway, you're not going to have any solar coming in. So I would say get the solar while you're out on the highway and then park under that shade tree when you're camping and have enough batteries to carry you through that. And you could also have alternator charging. You could start the engine for a few minutes, but you wouldn't need that either if you got sufficient batteries. Now, I know having a big battery bank is not the cheapest thing in the world, but that's my advice. The portable solar, I think it's people get obsessed with, like, I'm going to put the solar in the sun in the perfect spot, you know, out from under the tree, and I'm going to get the solar. And I think when people are new to solar, I mean, I'm not trying to insult you here, but people get really excited about the potential of solar and they want to maximize it. But like I said, you're not going to get any solar when you're going down the road. I would just bolt the thing to the roof, and if you park under a shade tree, don't worry about it. So that's my take on that. Hopefully that gave you something to go on. And then Rob, again, has a second question. Bar Victron monitoring, not sure. What are top things to do with van always connected to internet and how? I.e. turn on diesel heater, temp settings via Ruby. What options make most sense? The diesel heater should have its own thermostat, so I would go ahead and use that. I would not run that through the Victron Servo. The temp settings on the Ruby, you can have the Ruby sensor set off a relay on the servo based on some kind of temperature. I'm not really sure where that would be applicable other than turning on heaters for like your battery compartment. But really, the heating pads that you would stick on batteries or water tank, they have their own thermostat in there. Now, one student I had, he didn't like the thermostat setting in the heating pads, and so he ran it through another temperature-controlled relay where he could change the temperature at which point that heating pad would kick on. It had to be a little bit colder than the heating pad was going to kick on at 45 Fahrenheit, and he said that's too warm. I want it to kick on at maybe 40 Fahrenheit. And so he ran those heating pads through a relay where he could program it to kick on at 40 instead of 45. So he was trying to save battery power there. That's an application. I mean, honestly, let's make these systems as simple as possible. So if you don't need to run lots of relays with sensors, maybe don't do it. As far as things to do with the van always connected to the internet and how, if your vehicle is connected to the internet and you have Victron monitoring, I would hook it up to the VRM portal so you can track what your system is doing over time, and that's going to give you some insights onto how much solar you're producing, what your battery average state of charge is, and you're going to be able to get long-term trends and long-term view of what your system is doing. So hopefully that answered your question. Rob, one more time. If I don't have permanent solar panels, are there any watch-outs? Connect to shore power one time a month to keep the batteries topped up. Any other concerns? Well, like I said in your other question, I would do a permanent solar panel if you can, even if it's smaller. I know you have other things on your roof, which I recommend having an air conditioner or a vent fan up there. So I know your roof is not going to be covered with solar. But if you can get a solar panel on the roof, I would do that if you can. You said connect to shore power once a month to top up. That's a great strategy. Go ahead and top up once a month. Even if you do have permanent solar mounted, I would... shore power is going to be the most power you can get from any charging source, and it's a great way to top up the batteries. There are no other concerns that I have. I just think portable solar panels are a pain, but some people like them. I don't know. John says, hi Ross, I've been keenly following your van power courses, but because I'm sometimes overwhelmed by all the details, I've also been looking at what I'll call packaged power systems offered by companies like EcoFlow and Bluetti. Something that really attracted me to the latest EcoFlow unit was the ability to plug in and charge at an auto EV charging station. I did not see that in their latest equipment. Do you think this is a feature that other companies will soon be offering? By that I mean someone like a Sterling Power or Victron Energy, could they or would they offer a charging component that you could plug into an EV charging station? Technology's changed so quickly, just trying to see where things are going. Thanks, John from Summerland, British Columbia. Hey John. John's been a student for a while. As far as the EV charging, I did not see that on the EcoFlow. They came out with the new plug-and-play RV power systems. I'm still trying to get a hold of one of those myself so I can play around with it. That amount of power coming in to charge a car like a Tesla, I don't know if that amount of power could really be utilized. It depends on the size of the battery bank. I believe some of those charging stations are operating at 250 volts. I need to look more into this. I think you asked me this a year or two ago. I'm not sure. I think it's kind of like necessity is the mother of invention, and I think the shore power chargers that we have that'll put maybe 1500 watts or 120 amps, the multi-plus chargers that I use for shore power, they'll put 120 amps into your batteries. That's a 120 amp hours per hour of charging. So 2 to 3 hours to charge a standard battery bank from completely empty to full. And I think for most people that's enough. Let's say the EV chargers can put in 5,000 watts. You've got to have the battery capacity to store that. So I think with the electric cars, they have to have a massive battery capacity to push a 5,000 pound vehicle down the highway. The battery capacity for these camper vans, I just don't think is high enough to warrant that many watts of power coming in from an EV charging station. So I think, again, necessity is the mother of invention. So I think that if it's not needed, it's not going to be launched by Victron or Sterling Power. And Victron and Sterling Power are creating components based on people's inquiries. So I think they know the limitations that people are running into with their products, and they'll create a new product if they keep getting the same email over and over again. So you could email them over at Sterling or Victron and ask them about this, but they've got so many product updates that if they're not getting that many requests for this, they're probably not going to put it at the top of the list. So hopefully that helps. Thanks for the question, John. Rick says, Ross, what got you interested in van conversions? Thanks for asking, Rick. Basically, I wanted to build a van for my own purposes to break free from my monotonous life here in Houston a few years ago. And I loved building my van, and I loved traveling in my van. And I'm kind of a technical guy. I have an architecture degree, and I like to design things and tinker with things. So I'm a builder. I grew up in a shop. I grew up in the garage running machinery. And this is something I could build. When it came to the power systems, it was something that I enjoyed geeking out on and that people needed a lot of help with. So that's kind of how I ended up here. But I can help build the machinery, but I believe in the mission of getting out on the road and exploring. And so it really ties in kind of my passion for exploring with a passion for building things. And I discovered vans in 2014, and I've just kind of gotten deeper and deeper into it as the time goes on. So hopefully that answers your question. Thanks for asking. Old Johnny asks, I plan to put 6 solar on the roof of his RV/bus. There are 450 watt max amp or 11. The size are, they're 450 watt max amps 11, 52 volts per panel. That would be 66 amps, 52 volts in parallel, and 11 amps, 312 volts in series. What will I get the most out of? What type of gear do you recommend? I think 24 volt system is the best. With a 24 volt system, your voltage of your panels, I would go with the same 3 to 4 times the battery voltage. So in this case, that would be 72 to 96 volts. But I would, honestly, the 52 volts in parallel, 66 amps. The problem with 66 amps is a lot of the panel wiring is going to be like 10 gauge, and you really don't want to send more than about 30 amps through that. Whereas the 312 volts is way too high, 11 amps is manageable. What I would do is series parallel. So I would take 3 solar panels, put them in parallel, take your other 3 solar panels, put them in parallel, and then run those banks of 3 in series. And so let's see what you would get with that. You would get 52 volts max per panel. You would have, you would double that. So you would basically have 104 volts maximum with 33 amps. That's still a little bit high. What you could do is run the 33 amps, but upsize your solar cables to 8 gauge to carry the additional current. 10 gauge would probably run 33 amps because, let's be honest, with these solar panels, they're never going to hit that rated amperage. The short circuit current, they're never going to quite hit that number. But you could do 3 panels in parallel, 3 panels in parallel, and then connect those arrays in series. And like I said, you'd get 33 amps in this entire system running at 104 volts. So that's what I would go with. You just want to make sure that the charge controller that you go with can handle over 100 volts. So get one that can do maybe 120 volts. So hopefully that answered your question. I tried to be eloquent. That was a lot of details. But let's see here. Greg says, number 1, when to use a fuse block versus a breaker panel for 12 volt power and how to wire them properly. I'm building my Sprinter van from scratch, and I would think having the ability to easily turn off circuits would make a panel make more sense. Advantages or disadvantages of either, do's and don'ts to be aware of. Are there things you shouldn't run through a breaker panel like solar panel disconnect? I like to have the 12 volt fuse block backed by the power system, and then I run those branch lines out to switches around the van. Now, Blue Sea Systems makes switch panels that can be your breaker as well as your on-off switch. That's kind of personal preference. Personally, I like to hide all the fuses in the back and just have kind of tastefully appointed switches around the van. I like to be able to use switches that you would use in a house, and the appearance of the switch is important to me. I like to make it look kind of high end. The Bluetti switch panels look a little bit like a science project to me, or they look like you're in the hull of a boat. So I don't know, it depends on the look. I worked at a high-end van shop before, and they use those Bluetti switch panels before I got there, and I kind of got away from them. But I'll typically put my breakers and fuses there in the back, and I'll just put regular switches to turn my devices on and off. Let's see here. So that would be advantages or disadvantages. It's mainly aesthetics and what kind of switch you want to be dealing with every day to turn on your devices. And also the Bluetti panels are costly, so you can compare the cost. The PD5000 AC/DC distribution block, that's going to have your fuses as well as a place for your breakers, and those breakers are like $7 at Home Depot. So you can get into hundreds of dollars with the Bluetti panels. Number two, are there things you shouldn't run through a breaker panel like solar panel disconnect? Yes, so you want to pay attention to AC versus DC breakers because they're different. You can get a Bluetti surface mount DC breaker for your solar panel disconnect. I mentioned earlier I use the Midnight Solar baby box, and I'll put their MNEPV breakers. They're actually solar breakers in there. You may reference that question from earlier in the video, but yeah, typically your solar panel disconnect is not going to run through your standard breaker panel. So you're going to have breakers and fuses for your production side of your system, your chargers, everything coming in and out of your batteries. And then that's going to feed your breaker and fuse panel, and that's your AC/DC distribution panel, and that's typically going to be different breakers and fuses from the breakers and fuses that are controlling your charging and discharging of your batteries. So that's kind of like the production side and the consumption side. Those are different sets of breakers. So hopefully that answered your question. I've got one more from Carol. And Carol is asking about water filtration. I'll go ahead and answer this. I'm having trouble pulling it up. Carol, basically on the water filtration, you're going to use what you would use in a house. So I've used the GE water filters that you can get at Home Depot. They have 3 different grades of filters depending on how much you want to remove from the water. But what you could do is just have your water tank in your vehicle, and you have your line coming from that, and you're going to tee off. One of them is going to go straight to the faucet, and then the other one can go through the filter and then out of the filter up to a little filtered water spout like you would have in a house. I do recommend for your plumbing fixtures, just get what they have at the home improvement store. I would not use RV specific plumbing fixtures because it's usually going to be more cheaply made. It's going to be more expensive, and a lot of the stuff is small, like it's supposed to fit in a small space, but when you want to wash your face or wash dishes, you need the same amount of space that you needed in a house. So I wouldn't get all this miniature RV stuff. I would get the faucet and even the soap dispenser. There's a tip, because your soap will fly when you drive around. Get that soap dispenser they have in a house that's built into the cabinet, built into the countertop. But yeah, going back to your water filtration, I would just get a household water filter. I think for about $50. GE makes them, and you would just filter part of the water. Part of it would run straight to the faucet, part of it would run straight to that water filter, and that would go to its own filtered water spout on the top of the countertop. So I'll go ahead and leave it at that. I really appreciate you guys' questions. I know this was a very long video, but hopefully it was as valuable to you as it was to me, hearing all these questions and knowing what people are asking here in 2022. So if you guys dig this, please give it a thumbs up. And if you want to work with me, go to rosslukman.com/vanpower and get the Ultimate Van Power cheat sheet. And there's an opportunity there to work with me as well if you'd like to get a little bit more help with your project. So thanks for watching, and I'll see you in the next video.